Hello and welcome to lesson 7.6 on rational equations and applications. I'm going to break this video into two parts. The first one is just going to be how to solve the equations, so the algebra associated with that. Part two will be the applications section, which is going to be word problems and mainly how to write them as opposed to solve them. So this is really focused on how do you solve them. Okay, so I usually begin class with some sort of warm-up getting at how do you get rid of fractions when you solve equations, right? So ignore all these examples. I'm going to zoom into this. Here's some white space. So I'm going to just make up a warm-up real quick, right? Something like here's 2/3 plus 4x equals 5/6, right? And I might ask you, how could you solve for x without adding fractions, right? Because I know that what you could do is minus the 2/3 from the 5/6, get a common denominator. So it'd be 5/6 minus, 4/6, and then getting 1/6 there, right? You could do that, and that is a totally valid way of solving the problem. It's great. In fact, that's probably how I would do it. But there's another way, and a lot of algebra teachers show this method because, a lot of students struggle with fractions, right? Just to be honest. So if you ever see fractions, you say, well, how do I get rid of fractions so I don't, if they overwhelm you, you can just kind of get rid of them all, and then you don't have to worry about them anymore. And you say, well, the technique is to identify the denominator that you would multiply by such that all denominators cancel. You say, huh? What? I said, look at this. You have 2/3 plus 4x, 5/6, right? If you were to multiply this whole thing by 3, right? Well, the 3 times 2/3, the 3's would cancel, right? And then the 3 would multiply 4x. But then 3 times 5/6, well, 3 doesn't cancel the 6, right? So then that would change things and you could go from there. So what would be a number that I could multiply just by one time? I said, well, if I take the whole thing and multiply by 6, right? And I distribute this 6 to all terms in the equation. 2/3 times 6 is 12/3, which of course is 4. And then 4x, well, that times 6 is 24x. And 5/6 times 6, well, the 6's cancel, and you're left with 5. So that gets you 4 plus 24x equals 5, in which case you can minus the 4 now, and then divide by 24, getting x equals 1/24, right? And so this is a method that you kind of talk about in Algebra 1 about how to get rid of fractions. So that way you don't have to deal with these and you don't have to find common denominators, yada, 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 right? Okay, well, what are you doing? And why are you choosing 6, right? Because you could have chosen 3, but remember, if you did 5/6 times 3, that would just become 5/2, which doesn't get rid of fractions. Which means, okay, well, if you had 5/2, then you'd want to multiply by 2 to make it the 5. So you want to multiply both 3 and by 2. What you're doing is multiplying by the LCD, the least common denominator, right? Between 3 and 6, the least common denominator is 6. So you would multiply by 6, and this eliminates all of your denominators, right? Another simple, and I'm just going to be kind of as quick as I can with this. Erase all this. Another simple example would be like, I don't know, if you had 1/5 minus x equals 1/2, right? What would your least common denominator be? Well, it would need to be a number divisible by both 5 and 2. So your LCD would be 5 times 2, which of course is 10. And so you'd multiply everything by 10 here. 10 times 1/5 is 2, and then distributes to x is minus 10x, and then distributes to half is 5. And see, so multiplying by the LCD eliminates all the fractions, eliminates all the denominators. This works for algebraic expressions too, not just constant terms, yeah? And I guess that's a bit of kind of the difference between Algebra 1 and Algebra 2 here. So the premise is just already laid out. How do you solve rational equations? Multiply by the LCD. And when you do that, it gets rid of all these fractions and comes up with an equation you're used to. So an equation that you know what to deal with. So we're going to work with example 1 here. Start out with the LCD. Of course, I look at the denominators. 1 doesn't have a denominator. It's just 1 over 1. So that doesn't really matter. The only denominator I see here is the factor or term x minus 3. X minus 3. So your LCD is the term x minus 3. What that means is I'm going to take this whole expression and multiply by x minus 3. Now, this is distributing to all three terms. This is important to remember because what you're doing is, when you work with equations, you are allowed, as long as you do a math operation and it's the same operation on both sides, the equality remains true. So like if you were to square both sides, if you were to multiply both sides, if you were to add something to both sides, the equality will still remain true. And so I'm got to make sure that x minus 3 distributes to everything. So what happens here is you get x plus 4 over x minus 3 times x minus 3 plus 1 times x minus 3 equals 7 over x minus 3 times x minus 3. Yeah, that's what the distribution sort of looks like. And, as we kind of said earlier, right? Like if you had 6 times 5 sixths, I know a lot of you are in the habit, maybe you're saying 6 times 5 is 30, and 30 over 6 is 5. True, true, true. And that's fantastic, and that's wonderful. But you could save yourself time, right? Because when you have this 6 multiplying, it's like saying 6 on top, right? And so really, these 6's just cancel. So it's just 5. I just noticed that it's a common thing for students to be in the habit, be in the routine of multiplying the numbers on top. And that's fine. It works. But you can actually make your life a little bit simpler if you just recognize, this thing I'm multiplying by matches the denominator. So they divide each other. They cancel. Yeah. The reason I point this out, I say, x minus 3 cancels with this x minus 3. And this x minus 3 cancels with this x minus 3. And so what am I left with? I said, I'm left with x plus 4 plus 1 times x minus 3. Well, who cares? That's just x minus 3. And then the right side is 7. And this is what I was talking about. When you multiply by the LCD, it creates an equation that you know how to solve, that you've done before, that's something from prior algebra experience. This is now a simple linear equation. X plus x combines to 2x. 4 minus 3 is 1. And this equals 7. So I'll minus the 1 from both sides. And then I'll divide by 2, netting me x equals 3. Right? And thus we are done, and I found my answer. Except, have I? And there's something I haven't talked about yet, and I did this intentionally. The thing about rational functions, right? If you think about 1 over x, this function looks like this. What's its domain? Well, it's all real numbers except 0. And they say, why is that? Well, because 1 over 0, a number divided by 0, is undefined. So this function isn't defined at 0. And in Unit 7a, we've talked a lot about the fact that you should not divide by 0. And in Lesson 7.4, we also mentioned that when you're doing the algebra with these expressions, it's a good idea to state your variable restriction. So I would actually, before I do all this solving business, it would be a good habit to look at the expression I have and think, for what values of x would I cause division by 0, right? And I say, look at your factors in the denominator, x minus 3, both of those. If x were to be 3, that would cause division by 0, and we don't want that, so that we say x is not 3, right? 3 is not a number you want to plug into this equation because it's going to get you undefined results. And say, well, wait a minute. What answer did we get? So here, no, we're going. We say, whoa, we exclaim, right? That's 3. And we just actually said that, well, x shouldn't be 3. And so I said, well, we're actually going to reject that answer. I'm going to say, well, there's no solution, right? Because it shouldn't be 3. If you plug in 3, it's undefined. And that's the only answer we were able to find. So there's no solution. Remember, we call answers like this extraneous. They are a result of our algebra, but they don't actually work, right? They don't. When you plug it in, it doesn't actually satisfy the equation at hand. Okay, so that's one example. Here's another. Example 2. So I've got this equation. It would be a good practice, if you're going to find the LCD, then you need to identify all the factors, right? And so that means you want to factor all denominators. I said, well, look at the first fraction. X cubed plus 5x squared has a GCF of x squared. What's left behind would be x plus 5, yeah? And then, of course, the right side stays the same. There's no factoring to do on the right side, but sometimes there is. You never know. And so I say, okay, well, what's the least common denominator? Well, I need a factor of x squared, and I need a factor of x plus 5. And that's it, because that covers this denominator too. So looking at this, well, too big of an eraser there. Looking at this, I just say, okay, then I want to multiply by the LCD to cancel all these fractions. But real quick, before I do that, because I factored every denominator, because I know what the LCD is, what are my variable restrictions? What should x not be? I said, well, one of the factors in the denominator is x squared. So when is x squared equal to 0? Well, let's say when x is equal to 0. So I shouldn't have 0 in the bottom. And then x plus 5, when is this equal to 0? Well, minus 5 from both sides. X shouldn't be negative 5. So when I get my answers, I just want to verify that if I got a 0 or if I got a negative 5 or if I get both, then those actually aren't valid solutions to the problem, okay? I'll rule those out. Okay, so having this, let's multiply by the LCD. See, boop, boop. I say x squared times x plus 5. Fantastic. Okay. And so this is going to, of course, distribute. Now, here's the thing. You could do, and you know what? I'm going to do it for you, but I don't actually want you writing this in your notes if you're taking notes. You could write the distribution on every single term like what I'm doing right now. What I'm doing is in the numerator of every expression, I'm writing the LCD multiplied on top and bottom, right? And if you do that, of course, then you'll notice which cancels, right? These cancel, these cancel, these cancel, right? But personally, as your teacher and as the person grading this, hey, if you want to put this, that is fine, but you don't need to really do that. If you think you can do it in your head, go ahead. I can follow this. I already wrote it out, but just think about it, look at it. Here's the denominator, x squared times x plus 5. Here's what you're multiplying it by, x squared times x plus 5. What's going to cancel? Well, x squared and x squared cancel, and x plus 5 and x plus 5 cancel, which means you're just left with 5. And this equals, right? And then you've got this 4 over x plus 5 thing. Well, you're going to multiply this by this, so the x plus 5s are going to cancel. But what's not going to cancel is this x squared term. So the x squared distributes with the 4, getting you 4x squared. And then one more time, here's 1 over x squared. The x squared multiplied with this x squared, these are going to cancel. But then the x plus 5 isn't in the denominator, so it distributes to the 1. Of course, that's just 1 times x plus 5. So we say plus x plus 5. Yeah? Seeing this, well, that's a quadratic equation, and the way I solve quadratics is set them equal to 0. So I'm going to minus 5 from both sides, getting me 0 equals 4x squared plus x. And remember, when working with quadratics, the primary technique of solving, factoring. If it's factorable, you should do that when it's equal to 0. If it's not factorable, quadratic formula. Yeah? So 0 equals 4x squared plus x. That has a GCF of x. Pull that out, I get 4x plus 1. Thus, what are the roots? Well, when x is 0, that's a root. And when 4x plus 1 is 0, that's a root. Well, to solve for x on that, I would minus 1 and then divide by 4. And so I get two potential solutions here, x equals 0 and x equals negative 1/4. Now, hold on a minute. Before I box that and call it a day, what did I say x couldn't be, right? I said it couldn't be 0 or negative 5. Thing is, I got 0 right here. So that's not a valid solution. Therefore, this is my little 3 dots. Therefore, x is negative 1/4. And done. Yeah? Solved for x, and we have just a happy smile on our face. Happy. Okay. And so that's it. That is the premise of solving these. And to be honest, if you get that, you're good to go. Okay, you can click off the video. You can go to part 2. But I'm going to go ahead and work some more problems just for good practice, just for good measure, to kind of keep, getting the idea if you need to see a few more here. Okay. But again, if you get the idea, you're good to go. Yeah, have fun. All right, I'm going to work through some of these. And I'll be a little bit quicker. So I want to find the LCD so that I can multiply that to eliminate the fractions, right? Here's a common student kind of, I'm not going to say mistake, but I don't know, misguidance, right? You'd say, oh, the LCD should be x plus 1, and it should be x squared minus 1. And, well, the thing is that would work. If you multiply by that, it does work. But it overcomplicates things because it's not a least common denominator. It's just a common denominator. When doing this, you want to always make sure that you factor your denominators. X squared minus 1, that's a difference of squares, which factors as x plus 1, x minus 1. Therefore, the LCD is x plus 1, x minus 1. Both fractions have x plus 1, so that needs to be present. But then this fraction has x minus 1, so that needs to be present. Looking at these denominators, what would make these equal to 0? I would say x shouldn't be 1 or negative 1. Because if it's negative 1 plus 1, that's 0. If it's 1 minus 1, that's 0. So it shouldn't be those two numbers. Okay, now I'm just going to multiply by the LCD. So take this guy and multiply by x plus 1, x minus 1, right? The thing is this x plus 1 will cancel with this x plus 1, but you're still left with x minus 1. So the numerator is going to be 2 times x minus 1. And this equals, well, on the other side, both terms of the denominator cancel. And so you're just left with what's in the top, 1. Oh my gosh, what an easy equation. 2x minus 2 is 1. That means 2x is 3. That means x is 3/2. Thus, my answer, 3/2. And compare that to what it couldn't be. It couldn't be 1 or negative 1. And 3/2 is fine. So this is our answer. Ta-da! Yay! That's number 1. I'm actually going to save number 2 for last. Let's go to number 3. And I'll erase that thing right there. Okay, number 3. So same situation. We're going to make sure we factor every denominator. A lot of times you're going to find that the denominator really is just the factors of the other two fractions, but that's more so coincidence than anything. Okay, so I've set this up, and I've got, I just went ahead and factored this pretty automatically. It's negative 20 and positive 1. So what works? 5 and negative 4, right? That's why I have my factors, x plus 5, x minus 4. So I've already factored it, and I identify the LCD as x plus 5 times x minus 4, which is also present in that other denominator. So I'm going to multiply this whole thing by x plus 5 and x minus 4. Oh, and before proceeding, what can't x be? It can't be negative 5, and it can't be positive 4. So I don't want negative 5. I don't want positive 4. Okay. Well, let's go ahead and multiply these guys. This x plus 5 cancels. I'm left with x minus 4. So it's going to be x, the numerator right there, times x minus 4, the other term of the LCD that I multiplied by, minus, now this is 1 over x minus 4. The x minus 4's cancel, so it's just x plus 5. So it's minus 1 times x plus 5 equals, my favorite part is when this denominator matches this multiplier, because then that everything cancels. You're just left with what's in the top, which is 1. Distribution time, x squared minus 4x minus x minus 5 is 1. This is a quadratic that just needs a little bit of cleaning up, right? To solve quadratics, get everything to one side set equal to 0. X squared minus 5x, and then we're going to minus this 1, and that becomes a negative 6, which is equal to 0. Do an x puzzle, and you will find that it factors as x minus 6 times x plus 1. That's the correct factorization, meaning the roots are positive 6, negative 1. And if I go back up to my LCD and all this stuff in blue, what should I not be? I shouldn't be negative 5 or 4, but 6 and 1, 6 and negative 1 aren't that. So we're fine. We're chilling. Yay! Oh my gosh. Happiness, right? We're so happy. We're so joyful. Okay. We're having a great time, and we're going to do number 2 now. Now, interesting. What's funny is number 2 almost looks like the easiest one, but it ends up being, well, I'm not going to say the hardest one, but you'll see. Just stick with me here. Yeah. Always catches students off guard a little bit here. So what's my LCD? Well, notice the constant 4 is just 4 over 1, so you don't really care about that. Your least common denominator, you need a factor of x, you need a factor of x minus 3. Those are separate, by the way, okay? Sometimes students kind of think, I'm just raising, what questions do I hear from students, right? Well, that has an x and that has an x, so you just need an x, and then you need a minus 3. And I get the thinking, but remember that these are numbers, right? That x represents a number. So if x was 5, for instance, then 1 over x would be 1 over 5. But 5 over x minus 3, well, that would be 5 over 5 minus 3, which actually be 5 over 2. You see, so 5 is different from 2. So they're grouped together, right? The x minus 3 is a separate term from x. They're not the same thing, meaning you need both x and x minus 3 as your terms in the LCD. Okay, so now we're going to take this expression and multiply it by the LCD, least common denominator, and I'll just think what cancels. So for the first fraction, 1 over x, the x's cancel, and you're left with 1 times x minus 3. So I'm not even going to write the 1. I'm going to just say it's x minus 3. Plus, now the 4 term right here, it doesn't have a denominator, so nothing's going to cancel. 4 is going to get multiplied by both x and x minus 3, okay? Equals, on the right side, 5 over x minus 3. Well, the x minus 3 terms cancel, and the only thing left is 5 with x, 5 times x, okay? Okay, distribute x minus 3 plus 4x squared, because it's 4x times x, minus 4x times negative 3 is negative 12x. Negative 12x. And this equals 5x. Let's move everything to one side here. Put the 4x squared at the front. 1x minus 12x is negative 11x, minus 5x from both sides, that gets you negative 16x. Okay, so that's just me moving the x's over, and then the minus 3 is at the end here. Set this equal to 0. Okay, so time to solve. We do an x puzzle. 4 times negative 3 is negative 12, and then this is negative 16. So let's see, what gets you 12? 6 and 2, that doesn't get 16. 3 and 4, that doesn't get 16. 12 and 1, that doesn't seem to get 16. So, not factorable. Yeah. Does that mean there's no answer? No. No. That doesn't mean there's no answer. It just means you have to use quadratic formula. And so we sing the song. X equals negative b, which this is ax squared plus bx plus c. The negative b, well, that's negative 16. So that's just a positive 16. X equals negative b, right, like this. And so that's just 16 plus or minus the square root of b squared. Look, this is negative 16 squared, which is the same as 16 squared. So I'm going to say 16 squared minus 4ac, right? A was 4 and c was negative 3, all over 2a, where a is 4. Okay, and so then I just need to solve this, right? Now, one of two methods. Number one, this is on the calculator section, so you would have a calculator. Excuse me, I'm getting sleepy. Getting sleepy. Oh, that looks like a cool face. I was trying to do. How do you do restful eyes? Okay, I'm not going to bother you with that. I'm sorry for wasting time. So look, you can type 16 squared minus 4 times 4 times negative 3 in a calculator and get 304. And then you can do a little tree with 304, and you can keep on going like this. And that'll work out, okay? You can do that. I'm going to do it a different way. I'm actually going to notice that the 16 in there, see that 16 squared? That means 16 times 16. And this 4 times 4 is itself a 16. Now, because of this, that has 16 and that has 16. That means you can factor out 16 from the expression. So that means is you get 16 plus or minus the square root of 16 times the square root of 16 minus negative 3. See, what I did was I used this 16 as a GCF, pulled it out, and separated the square roots. And you're like, you're allowed to do that? I'm like, of course you can. We talked about that. Unit 6, right? Factoring out a GCF within the square root. And so then what happens here is I get 16 plus or minus. Square root of 16 is 4. And then 16 minus negative 3 is like 16 plus 3, which is 19. And then this is over 8. Then, of course, 16 over 8 is 2, and 4/8 is a half, so it's root 19 over 2. 2 plus or minus root 19 over 2. Oh, wait. Did I check for extraneous? Did I ever do my variable restrictions? Uh-oh, I didn't. What would make the denominator here 0? Well, if x was 0, or if x was 3. Well, considering the answer I got, I don't think that's 0 or 3. So 2 plus or minus root 19 over 2, I think that's fine. And that's our valid solution. And you might say, Mr. Spake, do we need to know the quadratic formula, like, for real, for tests and stuff? And I say, yes. Yes. You should, yeah? Always don't ever forget quadratic formula. If it's not factorable, quadratic formula. Yeah, happens a lot. That's why we have it. That's why we talked about the quadratic formula. Of course, you could always complete the square. You could do that too. But y'all haven't done that in a while, have you? Anyway, that is it for part one. I hope these examples were nice and happy and a good time. You say, we're very happy. Look at us. We've got a little hat. There's our little hat. And there's our face. And there's our ears. And we're just having a good time. Yeah? So anyway, that's it for the video. This hopefully gets at the idea of using the least common denominator to solve. Most of this was actually just quadratics review, really, right? Once you find the LCD and multiply it, you just note the extraneous possibilities and solve accordingly. So there you go. That's part one. Next up will be part two. That's going to be the next video, which is on application problems. So some word problems on this stuff. Buckle up. It's fun. Anyway, I'll see you in the next one.